So that raises an interesting question. Does NASA try to be ingenious with the use of funds? Because obviously space research is very expensive. Is it always looking for cost-cutting methods?
Oh, absolutely. James Webb Space Telescope, for example, we've teamed with the European Space Agency. So they're doing the launch vehicle and some of the instruments. So international cooperation is one way. New technology is the other. That's what Russ has been working on, is technology so that you can do things you couldn't imagine a decade ago a lot more affordably.
Yep. Well, you're mostly trying to work on narrowly defined missions, or you're trying to build a broad platform that can support a whole array of projects?
Well, we do both. The way NASA does decision-making in science missions is every 10 years, the National Research Council brings together all of the scientists in a particular discipline and comes up with what they call a decadal survey. And this survey is the consensus of our scientific community of what can we do, what do we need to do, and what's feasible in the next decade. Then, of course, NASA tries to translate that into real instruments. Now, sometimes we get cost overruns and things get pushed out. Other times we find a new technology or a new way to do it, and we can do things faster.
Well, who decides what NASA works on? Who decides what projects will get a green light and which ones won't? Does Congress decide? Is it the president, or is it internal, like NASA proposes, subject to Congress opening the purse strings?
Well, as a U.S. government agency, of course, we have many bosses. Ultimately, it's the taxpayers. But the scientists give us the list of what they want done. Then we translate those into proposals. We submit those to the White House, to the Office of Management and Budget in the Science Advisor's office, and they then will maybe readjust those or readjust the balance between astrophysics and earth science, for example. And then that's submitted to Congress, where the congressional committees go through, and we get a lot of help from our 550 or so board of directors, and then we get an appropriation and move forward. But it's a lot of interaction, and it's really a very exciting process, and I think it works pretty well.
Yeah. Is there a general consensus? In the early days of the space program, it was really popular, and we were competing with the Russians. Nowadays, is it still easy to get funding? Is there still a lot of support for space research?
It's never easy to get funding. We have to make a very good case that we're going to do these things affordably, and that they are the key science questions if it's a science mission, and that this science area is what the public and the Congress is interested in. On the other hand, NASA has very broad support. Our budget it may seem like a lot of money. It's a little over $16 billion, but it's a few tenths of a percent of the federal budget. So we're not one of the really big areas, but the support of it is very, very broad. We find that we do surveys, the public says, look, NASA's a good thing.
Now, what's the biggest need in space research? Is it the propulsion systems themselves, the ability to get stuff out there faster and more dependably, or is it more the optics, the instrumentation?
Well, for this problem, the exoplanets, and Russ has a lot of expertise on that, it's really the optics.
And I guess the question of propulsion versus telescopes is an interesting one, because particularly here, because we cannot with foreseeable technology actually go to these planets. However, we can go there remotely, if you will, with telescopes and survey those systems remotely. And actually, our remote sensing in this sense has surpassed the technology of Star Trek, because in Star Trek you actually had to go to a planet system in order to be able to determine what planets are in that system. And we, with obsolete 21st century technology, can already do that, even though we cannot come close to Star Trek's propulsion of actually going there.
Now, speaking of optics, you've got a little optical device on the table. We just have a couple of minutes left, but maybe you could just give a very quick demonstration of that device.
Absolutely. So these are some of the optics that I use in my lab and my group use in the lab to test how well we can block a star. To block a star, we use instruments called coronagraphs, and these are components of a coronagraph.
We only have 1 minute left, so you'll
Sure.
have to...
So one key component is masks that block the star, and this is the kind of mask. And another type of component is optics that modulate the light in some way, like this lens here. So you can see it's not a typical lens, it's kind of a fancy lens that does weird things to my eye.
So you can create your own little eclipses by... This will actually block out the stars so the planet is more visible?
That's right. This can create an internal eclipse inside the telescope.
I'd love to ask more questions, but unfortunately we are out of time, and I'm sorry about that. I'd like to thank both of you for being here today. Peter Worden, Director of NASA's Ames Research Center, Wasserman Belikov, astrophysicist at Ames. Thank you for watching. Visit our website, www.futuretalk.net. For Future Talk, I'm Marty Wasserman. We'll see you next time.